In this video, I will show you how to multiply one matrix times another matrix. But first, we have to decide, can you even multiply these matrices together at all? So check the dimensions. The dimensions of the first matrix are 3 by 2, 3 rows and 2 columns. The dimensions of the second matrix are 2 by 2, 2 rows and 2 columns. You can only multiply two matrices together if the inner dimensions are the same. These dimensions are the same, so this will be possible. The outer dimensions tell you what the dimensions of the final answer will be. So our final answer will be a 3 by 2 matrix. And I'm actually going to use that information right now because we're going to set up a giant 3 by 2 matrix like this. All right, so here's a very large 3 by 2 matrix for us. Now, we are going to grab the rows from the first matrix, and we are going to grab the columns from the second matrix. And it's very straightforward because the first row goes across the first row. So that's why I'm going to put 0, -4, 0, -4. Yes, even though rows are horizontal, you write them vertically for multiplication purposes. The second row is going to go across the second row. So I will have 1, -2, 1, -2. The third row will go across the third row. So I will have 0, -5, 0, -5. Now it's time for the columns. Column 1, you guessed it, goes down column 1. So I will have 4, -5, 4, -5, 4, -5. And column 2 goes down column 2. So that will be 6, 5, 6, 5, 6, 5. Next, we multiply these. So that's going to give me 0 and 20 and 0 and -20 and 4 and 10 and 6, also -10, also 0 and 25, another 0 and -25. The final step is to add up these numbers. So I will have 20, -20, 14, -4, 25, I feel like I need a little bit more space down here, 25, and -25. And then you write your final answer like this. Let's see what happens when we multiply this matrix times this matrix. Well, first we have to make sure that this multiplication is even possible. So we need to check the dimensions. So the dimensions of the first matrix are 3 by 2 because it has 3 rows and 2 columns. The dimensions of the second matrix are also 3 by 2. This is going to be a problem. In order to multiply matrices, the inner dimensions have to be the same. because these dimensions are different, I have a 2 and a 3, that means that this matrix multiplication is undefined. And that's good news in terms of this is one less problem that you have to do. Undefined is a lot quicker, at least. So the last problem turned out to be not possible. So let's see if we can do problem number 9. Let's check the dimensions. The dimensions of this first matrix are 2 by 4. There are 2 rows and 4 columns. So this is a 2 by 4 matrix. Now the dimensions of the second matrix are 4 by 2. All right, because there are 4 rows and 2 columns. For matrix multiplication to be possible, the inner dimensions have to be the same. And they are, so we're good. The outer dimensions tell you the dimensions of your final answer. So our final answer will be a 2 by 2 matrix. We actually need that information right now because we need to set up a giant 2 by 2 matrix in order to do the problem. So here is a big fat 2 by 2 matrix. All right, I probably did not need to make it quite this big. All right, I got carried away. All right, sue me. Now, the way it works is we are going to grab the rows from the first matrix and we are going to grab the columns from the second matrix. Let's start with the rows. Row 1 is going to go across row 1. So we will have 4, -6, -4, -1. 4, -6, -4, -1. Row 2 will go across row 2. So we will have -6, -1, 3, 0. -6, -1, 3, 0. Now let's do the columns. We will grab column 1. Column 1 goes down column 1. So we will have -4, 5, -3, -6. And again, -4, 5, -3, -6. Now, column 2 will go down column 2. So here we will have -4, 0, 1, -1. -4, 0, 1, -1. Now it is time to multiply. So here we will have -16 and -30 and +12 and 6. -16, 0, -4, +1, 24, -5, -9, and 0. 24, 0, 3, and 0. All right, finally, we're just going to add these up. All right, so if we add up these numbers, we're going to get negative 28 and negative 19 and 10 and 27. So that's why the final answer will be these four numbers. The final answer is the matrix negative 28, negative 19, 10, 27. Let's do another problem. Let's multiply this matrix times this matrix. It seems clear that this is going to work out, but let's go through the motions anyway. The dimensions of the first matrix are 2 by 2, and the dimensions of the second matrix are also 2 by 2. Matrix multiplication is only possible if the inner dimensions are the same, which they are, so we are good. The outer dimensions tell you the dimensions of your final answer. So that tells us that our final answer will be a 2 by 2 matrix. So what you do is you go ahead and set up a large 2 by 2 matrix for yourself. All right, it really didn't need to be this large, but I had the space, so I used it. Now, the rows are going to come from the first matrix, and we're going to steal the columns from the second matrix. All right, and it's very straightforward because row 1 goes across row 1. So we have negative 3, 0, negative 3, 0. Row 2 goes across row 2. Negative 4, negative 6, negative 4, negative 6. Now it's time for the columns. Column 1 goes down column 1. So 6, negative 4, 6, negative 4. Column 2 goes down column 2. So negative 2, negative 6, negative 2, negative 6. Now it is time to multiply. So we will get negative 18 and 0 and 6 and 0, negative 24, positive 24, positive 8, and positive 36. So finally, we add up these green numbers. So this will give me negative 18 and 6 and 0 and whatever this is, 44. So the final answer is going to be the 2 by 2 matrix, negative 18, 6, 0, and 44. Looks like I still have a little more time on this video, so let's do another problem. First, let's check to make sure the matrix multiplication is going to be possible. The dimensions of the first matrix are 2 by 2, and the dimensions of the second matrix are 2 by 4. For matrix multiplication to be possible, the inner dimensions have to be the same. These are the same, so this is going to work out just fine. Now, the outer dimensions tell you the dimensions of your final answer. So the final answer is going to be a 2 by 4 matrix. So that tells me that to do the problem, I need to set up a rather large 2 by 4 matrix. Okay, now I'm going to snatch the rows from the first matrix, and I'm going to grab the columns from the second matrix. Let's start with the rows. Row 1 will go across row 1. So that's why I will have 4, -4 everywhere. And then row 2 will go across row 2. So I will have -3, -6 all the way across. Now it's time for the columns. Okay, column 1 will go down column 1. So we will have -2, 4. Column 2 will go down column 2. So 1, -4. Column 3 will go down column 3. So we have 4, -6. And column 4 will go down column 4, 1, 2. Next, we multiply. So that's going to be -8. I'm having to squeeze this in here. -16, 4, +16, another 16, 24, 4, -8, 6, -24, -3, 24, -12, 36, -3, -12. So the final step is to add. So we're just adding the green numbers together. So this is going to give us -24 and 20. And 40. And -4. And -18. And 21. And 24. And -15. But you can't just leave it like that. You have to go ahead and write your final answer as its own matrix like this. So this 2 by 4 matrix is the final answer.